Hello, we are discussing about GATE 2001 ECE paper, and this question is related to analog circuits. The current gain of a BJT is defined as A. Gm R naught, B. Gm by R naught, C. Gm into R pi, D. Gm by R pi. So the answer for this question is C, but instead of saying directly like this, to remember this one, we will go with a short derivation which includes the concept. So we will go through the concept, we will derive a small derivation. From that one we are going to find this current gain of a BJT, beta is equal to Gm by R pi. Okay, so current gain of a BJT is nothing but simply it is beta. Okay, and current gain of a BJT is defined whenever the BJT in linear region, linear or active region, it is also called as linear or active region, then only the BJT is going to be acting as amplifier which can provide current gain as well as voltage gain. So first of all, BJT has to be kept in active region, then you can apply a small signal to get the current gain as well as voltage gain. So this is what the general CE amplifier circuit. So for this CE amplifier circuit, this is what the transistor you bought from the market, and the terminals for this one is nothing but collector, this is base, and it is emitter. Okay, so whenever you are going with a simple transistor and if you apply directly input signal Vin, at that time it won't amplify, it must be in active region, and we are going to use this R1, RC, R2, RE, such that along with VCC, these 5 elements are going to be provided to keep the transistor in active region. This process is called as biasing. Biasing the transistor is nothing but keeping the transistor in active region. Okay, now whenever you keep like this, at that time the currents flowing through this one are all going to be DC currents. This current is nothing but it will become IC, and this will become IB, and this is IE. The current flowing through this one is capital IE. Since we are dealing with plus VCC, which is constant, DC power regulated power supply, R1, R2, RC, RE, these are all constant resistances. So whenever you are biasing with these constant parameters, at that time the currents also flows are going to be constant. Constant currents, that is DC currents, are going to be indicated with capital letters with capital suffix. So IC, IB, IE are going to be the terminal currents when only DC is going to be considered. Now we can say that when the transistor is in active region, if you apply AC signal like Vin, by that time this is going to be superimposing on these voltages, so that now you will get more current, that is the current flowing through the previous, whatever the current flowing through previous, it will be modifies, it will change accordingly the V input. So because of this V input which superimposes on the previous voltage and currents, you will get extra current, that is nothing but V input is nothing but small signal current, remember that one. This is AC current, AC implies nothing but small signal voltage, because of that one you will get small signal currents. So plus I am writing it as IB is going to be small signal current, plus IC is nothing but small signal current, small signal collector current. So total is nothing but instantaneous collector current is going to be called as, this is small I with capital C as suffix. Here it is also B implies nothing but, okay, small I capital B is nothing but total instantaneous collector current. This is the notation we will use. So here I am going with the notations which combines both AC and DC. So this is small v capital BE is nothing but total instantaneous base to emitter voltage, which you can write it as capital VBE plus small VBE. Okay, next capital IC, sorry, small I capital C is nothing but, you can write it as small IC plus capital IC, that is DC current plus AC current. Okay, so in general we know that one, the emitter current is approximately equal to collector current in active region. From that one we are going to derive the required equation. Okay, so look at this one, these things now we are going on a separate page. So we know that one current gain is defined as beta, which is nothing but small collector current, small signal collector current by small signal base current. This is what. And now we know whenever we are going with DC currents, at that time we know that one IC is equal to, that is DC collector current is approximately equal to IE. IE is nothing but emitter current of BJT whenever it is in active region. Active region means emitter base junction forward bias, collector base junction reverse bias. IE is nothing but current flowing through emitter base junction which is forward bias. Whenever the junction is in forward bias, it simply acts as diode. So that IE can be approximated as, okay, I naught into e power VBE, this is capital VBE by VT minus 1. This minus 1 is going to be very small because VBE is positive, so that it can be approximated as I naught times of e power VBE divided by VT. So from this one we can write like this: IC is equal to I naught times of e power VBE divided by VT. This is equation 1. So DC collector current and DC base to emitter voltage are going to be related by this equation. From this equation you can write the for total instantaneous collector current also. For total instantaneous collector current, small I with capital C is equal to I naught. I naught is going to be a constant one, okay, which is reverse saturation current multiplied by e power. This VBE now has to be replaced with total instantaneous VBE. So small v with capital BE divided by VT, which you can write it as small IC plus capital IC. This is second equation. Now from this one I am writing this one, I naught into e power VBE by VT. So this can be simplified into e power capital VBE separate plus small VBE separate by VT. And from this one e power a plus b is nothing but e power a into e power b. Using that formula we can write it as capital VBE by VT into e power small VBE by VT. And this portion, if you are looking at, it is nothing but simply it is equal to IC. So capital IC into e power VBE divided by VT. This is nothing but total instantaneous collector current. From this one we know that one VBE is nothing but small signal voltage, and VBE is generally very small compared to VT. VT is nothing but thermal voltage whose value at room temperature is 25 millivolts. So the value of VBE is very small because VBE is base to emitter voltage, and that too the emitter junction is forward bias. For a small change in base to emitter voltage itself, there will be a large change in the collector current produces. So VBE is very small compared to VT. So because of this one we can write total instantaneous collector current IC is equal to IC multiplied by this one I am writing now, e power VBE by VT can be approximated as 1 plus VBE by VT. So this, if you are going to make it, IC can be taken inside, IC plus IC into VBE by VT can be written. So this is nothing but from second equation. This is total instantaneous collector current that can be written as sum of DC collector current with AC collector current. Now if you check, if you compare at that time IC and IC get cancels, so small signal collector current that is small I small c, which is nothing but we can write it as IC divided by VT into VBE. This you can write, okay. And generally this is one equation. From this one if you write at that time you can write it as IC divided by VBE, that is small signal collector current by small signal base to emitter voltage, which is nothing but output current divided by input voltage, which is transconductance. It can be defined as GM. So GM is equal to IC by VT, which is third equation. GM is equal to IC by VT. And one more parameter we are defining, small signal input resistance. Small signal input resistance at base to emitter junction. At base to emitter junction, it is indicated as JE, emitter junction or base to emitter junction. When looking into base is going to be defined as R pi. R pi is the parameter which is going to be called as small signal input resistance at emitter base junction whenever you are looking into base. You don't get the same input resistance if you are looking into emitter, because base is separately differently doped and emitter is differently doped. So the currents flowing through the base and emitter are going to be different. So whenever you are looking into base as well as emitter, even though you are going for the same base to emitter junction, you don't get the same currents. For that one, we can define the resistance with respect to base is different, with respect to emitter is different. Here we are defining small signal input resistance of emitter base junction whenever you are looking into base. Okay, that is nothing but R pi. It is simply RBE also can be called. R pi is nothing but, okay, you can think in this way. Okay, this is what the transistor symbol. For this transistor symbol, this is what emitter base junction, base, and it is emitter. But the current flowing through this one is nothing but IB, and current flowing through this one is nothing but IE. So if you are looking from this side at that time, voltage is going to be same. This is VBE only. Voltage from base to emitter is same, but whenever you are looking into base side, that resistance is going to be called as RBE. Okay, is going to be treated as VBE divided by IB, you can write. Whereas if you are going with emitter first at that time, so it is called as RE. By that time it is VBE divided by IE. Both are going to be different. So this generally called as R pi and it is defined as RE. Even though you are going for the same junction, but the current flowing to both ends is different, so that you can get two different resistances. So one whenever you are looking into base, one the other is whenever you are looking into emitter. So I am defining it whenever you are looking into base. So R pi is equal to VBE divided by IB. Okay, IB is nothing but you can write it as VBE divided by IC by beta, you can write IC by beta, because base and collector currents are defined with respect to beta. So IC is equal to beta IB, so IB is equal to IC by beta, you can write. So from this one, R pi is equal to beta times of VBE divided by IC. From this one, VBE divided by IC is nothing but GM from third equation. So beta into 1 by GM times. From this one you can write it as beta is equal to, beta is nothing but current gain of BJT, that is GM into R pi. GM into R pi. So this is what the required equation. Current gain of a BJT is nothing but GM into R pi. So the right answer for this question is C. Beta is equal to GM into R pi. Thank you.